We're going to talk about a few different types of exponents today. First one is zero exponents. So any number or variable raised to a zero exponent equals 1. So for example, if I have x to the 0 power, that equals 1. If I have 3 to the 0 power, that equals 1. If I have 1,562 to the 0 power, that equals 1. Anything to the 0 power equals 1. So for negative exponents, I want to show you this pattern here. If I raise 10 to the third power, 10 cubed, that gives me 1,000. 10 squared is 100. 10 to the first power is 10. And 10 to the 0, as we just found out, is 1. And we can kind of see a pattern here. Every single time we subtract 1 from the exponent, we're actually dividing the result by 10. And we can see if we divide 100 by 10, we get 10. We divide 10 by 10, we get 1. So we're going to continue this pattern, and I'm going to, now we're going to go into negative exponents. So I'm going to take that 1 and also divide that by 10, and that's going to give me 1 over 10. And we're going to do it one more time. Divide by 10, and that's going to give me 1 over 100, or 1 over 10 squared. So here's the rule with negative exponents. If I have any term to a negative exponent, we'll call it negative n, that's going to be equal to 1 over a to the positive n. So it goes into the denominator and the exponent becomes positive, just like we saw here. This would actually be 10 to the first power. This is 10 squared in the denominator. Same thing happens if we have a negative exponent in the denominator. We're going to just relocate it, actually put it in the numerator, and make the exponent positive. So we'll see some examples of that in just a minute. So here's the first example, and I actually want to just address the negative exponents first. Let's get rid of those, change them to all positive exponents. So I'm going to take the y to the negative 1, and I'm just going to cross it off and move it to the denominator and make that exponent positive. Y to the negative 4th, I'm going to cross that off and move it to the numerator and make the exponent positive. So again, if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. And now we can continue from here. So I can divide out an x squared from the numerator with an x to the 4th in the denominator. I'm left with x squared. I'm going to divide out a y from the denominator with a y in the numerator, and I have y cubed. Excuse me. So in the numerator, I'm left with 2y cubed, and in the denominator, I just have x squared. For this next example, again, I'm going to take the x to the negative 2 out, and I'm going to put it in the denominator. Let's hold the spot in the numerator with a 1. And then I can just combine those x's in the denominator here by adding the exponents. So this becomes 3x to the 6th power. For next example, we're going to just follow the rules and add the exponents. Let's go ahead and address the coefficients first. We're going to multiply those. So 4 times 2 is 8. And then I have x to the 4th times x to the negative 4th. If I add those exponents, that would be x to the 0. And then y cubed times y to the negative 2. Again, I'm going to add those exponents, and that would just give me y to the first power. I'm just going to simplify this here. This is actually 8 times 1 because x to the 0 is 1, or 8y. And the next example, multiply the coefficients. So this becomes 9. And this is u squared times u to the 0. Now u to the 0 is just 1, but I'm just going to add those exponents anyway. So this becomes u squared, and this is v. Add the exponents, that's v to the negative 5. A general rule of thumb, we want to leave our answers with all positive exponents. So this v to the negative 5 moves to the denominator and the exponent becomes positive. Everything else stays in the numerator. So that's our final answer. There's nothing else we can reduce there. We are going to continue talking about this in class. See you then.